Hello, everyone, and thank you all for joining us today. Our webinar is The Advantage of Evonik's Innovative Polycarbamide Technology for One-Day Flooring Systems. Your presenter today is Shafiq Fazal. Mr. Shafiq Fazal is a technology manager at Evonik Corporation in the Crosslinkers business line. His current focus is developing new products, including polyurea, high solids, and waterborne epoxy curing agents for coating applications. Mr. Fazal brings over 25 years' experience in R&D and applications development in various fields, including polymeric materials for electronic displays, conducting polymers for organic light-emitting diodes, nanoparticles for coatings and elastomers, and polyurethanes for adhesives, elastomers, and industrial coatings. My name is Abby Pirro with UL, and I'll be moderating today's webinar. Please send us your questions by typing them in the question box located on your screen. Our panelists will answer them at the end of the presentation. We are recording today's event and we'll send you a link by email when it has been posted to ulprospector.com. Now I'd like to turn the presentation over to Shafiq. Would you like to begin?
Thank you, Abby, for the introduction. I would like to first thank all of you for joining us today. My name is Shafiq Fazal, and I will be discussing the advantage of Evonik's innovative polycarbamide technology for one-day flooring systems. So the agenda of my presentation, I'll start out with the introduction on resinous or seamless flooring systems, the purpose, and then also talk about the key market trends. Then get into the polycarbamide technology for flooring applications, introduce the three commercial curing agents from Evonik, Amicure IC 221, 321, and 322. Then I'll follow up with discussing the synergies you get by combining the epoxy technology with polycarbamide technology. Then give you a couple examples of flooring systems, one-day flooring systems, and then I will conclude my talk. Okay, so let's begin. So first I will start out with talking about the application. So these are pretty much a floor coating or resinous or seamless flooring over concrete. And what is the purpose of applying a coating over concrete? The main purpose here is to protect the concrete or protect the asset. As you know, concrete is a very strong material. However, over long periods of time, it does not have very good durability. And also in terms of chemical resistance, especially against acid resistance, is not really good. So really the purpose here is to protect against mechanical and chemical impact. Another reason is actually protect from the influence of concrete. Over time, concrete can form dust, and also concrete is a porous material. So now you actually have moisture vapor coming up to the surface, bringing up some soluble salts. So now you have efflorescence on the surface of the concrete. Another is, through thermal expansion, contraction, you have crack forming on the concrete surface. So applying a coating on top of the concrete, you're really protecting from the influence of the concrete. Third reason is really forming a homogeneous coating on the surface of the concrete makes it easy to clean. So there's no places for crevices and other things, for bacteria or microbes to grow. So it makes it easy to clean, and again, you have a nice hygienic space. Also, safety is another reason. By applying some kind of self-leveling coating on the surface of concrete, you're able to even out the surface in terms of forming a smooth surface. And also, you're able to designate certain areas by markings. So you can designate, the use of like walkways, storage, and working areas, again, through marking on the coating itself. Also, specific functional properties like chemical resistance, yellowing resistance, and abrasion resistance can be improved through the use of resinous or seamless flooring. So all these reasons I gave you were functional reasons for putting a coating down, but there's also the aesthetic reason. No one wants to look at bare concrete itself. You really want a nice design. So there's also aesthetic, a reason for applying the coating on the surface of the concrete. As you see here, it's a kind of example of a type of seamless flooring system. As you see, it is really a multi-layered type of coatings. It's not just one layer of coating applied to concrete. The reason is, you start out with a primer. You want something that has good adhesion to concrete, and also should have a good intercoat adhesion, so subsequent layers can be put on top and it can stick well to the concrete as well. The next layer will be a mid coat, and this is usually to build up the film to get the high strength and dimensional stability and improve the load bearing strength. And then finally, a top coat is used to improve the UV resistance, chemical, and wear resistance. And kind of here, a couple of pictures you see down here are examples of seamless flooring applied over concrete. So what is the market trend in flooring industry? I can sum it up in 3 words: better, faster, safer. By better, what we talk about is enhanced product performance. What you're trying to do is improve the aesthetics. Again, chemical, abrasion, resistance, UV stability. What we really want is the coating to last a long time. You do not want to come back every year or every couple of years and have it to replace the whole flooring system. The next one is faster. So what we're talking about here again is productivity improvement. The technology that you use for coating has to cure very quickly, and sometimes also under low temperature conditions. So again, it's really fast cure. The benefit here for the applicator is that they can finish the job quickly. Sometimes just in 1 day, they can finish the job and then move on to the next job. For the end user, the benefit is minimum downtime. So minimum downtime allows them to come back quickly and start again, if it's start their production or their operation quickly. So again, that's the benefit to the end user. The last one is safer. So again, we talk about use of environmentally and user-friendly materials for coatings. As you know, that is you're trying to protect the applicators. So you want to use low to zero VOC materials, again, low odor type of materials in coatings application, but also you're trying to protect the occupants of that space. Over time, you do not want something to emit out from the coating that's harmful to the health. So you want something to have low emissions. So which technology can meet all those 3 market trends? And this is where I'm going to start talking about the polycarbamide technology for flooring application. This technology brings a unique combination of UV stability, ultra fast return to service, low temperature cure, high abrasion and chemical resistance, and also allows for varying finish. And so again, we talk about aesthetics. Here you can apply high gloss finish and also low gloss finish. Polycarbamide is not a term that you hear often. And what we talk about polycarbamide is really an amine cured polyisocyanate resulting in 2 amines joined together by a carbonyl functional groups. For those who have background in chemistry, really we're talking about polyurea or aliphatic polyurea, or something that's commonly used in the industry right now is polyaspartic. So it's, in terms of chemistry, it's very similar chemistry. It is a thermoset technology, and by that we mean it's really you're taking 2 parts, part A being the polyisocyanate resin, mixing it with amine curing agent, which is part B on the job site. And after you mix it together, you have only a certain amount of time that you have to work with it because they start reacting together, and then you're applying it onto the substrate. And so what we're talking about is flooring application. So generally the application, the way it's applied is through squeegee and roller, on the floor. Here's a little, chemistry here in terms of, again, we talk about polyisocyanate resin. So you have a molecule with NCO functionality, and these NCOs will react with the amine functionality in the amine curing agent. And generally, again, you have multifunctional systems, so you can get good cross-linking and good network formation for improved performance. And then what you form as you react them together is really these urea linkages on the molecule, okay? So in terms of polyisocyanate, I'm not going to be talking about it, a lot in my discussion. In terms of what really is used is generally hexamethylene diisocyanate trimers or biorets, and there are various commercial suppliers of those resins. My focus will really be on the amine curing agent and specifically talk about our polycarbamide technology, the trade name Amicure IC. Now I will introduce the 3 commercial curing agents for flooring application. And so, we do have products for metal application and other substrates, but really my focus really will be on the flooring application, specifically over concrete. And the 3 curing agents are Amicure IC221, IC321, and IC322. IC221 is a fast cure at low temperature and low humidity conditions. IC321 has lower reactivity, so slow reactivity, so it's again slower cure, has longer working time, better for higher temperature and higher humidity. And Amicure IC322 is more similar to IC321 in reactivity. However, what it does is adds the ability to customize the sheen. And what we talk about here is, without matting agent, you get a nice high gloss finish. With the matting agent, you can get the down glossing, so you can get down to satin finish. If you look at the curing agent properties of these three curing agents, you look at they all have very low color. The amine equivalent weight is about 375 to 400. So what it does is allows for 2-to-1 mix ratio with the polyisocyanate resin. The viscosity at room temperature are really low. So these are all below 350 centipoise. So the benefit there is it allows for to formulate a solvent-free coating. And as you see with the VOC as supplied, these have hardly, these have low or no VOCs in terms of 221 and 321. IC321, IC320 does have less than 100 grams per liter VOC, and that's coming in from the modifier that's used in the curing agent. However, that modifier does not have any odor, so you are able to apply it, and there will be no odor with the coating. Okay, so now kind of get into the handling and performance properties, and that's when used with the standard polyisocyanate. So these are properties after you mix in with the polyisocyanate. So mixed viscosity, once you blend them together, you start out with about 1300. So they're all pretty much, IC221, 21 are in the 1000 centipoise range, 322 being a little lower in terms of mixed viscosity. So these are all in the range where you can still apply it without need for solvent. And if you use a lower viscosity grade polyisocyanates, you can even get lower mixed viscosity. Viscosity build, so what we're talking about is viscosity as it builds in the bucket after you mix part A and part B together. Again, a lot of times, after you mix the two together, you're not going to be keeping the material in the bucket. You are going to pour it out on the floor and start the application. But the viscosity build, as you see, 2221 is faster, so you get 20 minutes to 12,000 centipoise. With 321, you have 50 plus minutes, and 322, you have about 70 minutes to 12,000 centipoise. Thin film set time, that's the important property here. So how fast does it cure? So what we talked about in terms of cure time is really at ambient conditions, 22 Celsius, 50% relative humidity, and 221 has about 2-hour cure time. 321 and 322 have about 6 hours. I will kind of discuss a little bit more in terms of what happens at lower temperature, higher humidity later in the presentation. The Shore D hardness are generally, these are hard coatings, so greater than 70 Shore D. And also, so impact resistance, so in terms of flexibility, you see very good flexibility. You get very high flexibility, greater than 160 inch pounds for all these coatings. So it's unique in terms of getting very high hardness, but also very good flexibility as well. So these coatings are very tough, and that makes them very durable. Table abrasion. So you see the values for table abrasion are around 40 milligrams loss, more in the area of what polyurethane coatings bring. So very good abrasion resistance. Tensile elongation and break, the reason we show this is that these do have some flexibility. Again, a lot of times like epoxies, they do have high tensile strength, they have high hardness, but generally the elongation is very low, but these do have some flexibility, as you can see here in the numbers. Finally, UV resistance. So as I mentioned, these are light stable systems. So you can see the accelerated aging testing, delta E, these are very low. So that means, again, these have very good UV resistance and can be used for indoor or exterior application. My next slide, something I'm sure you're all interested in terms of how does the polycarbamide technology compare with other technologies. So here I'm really looking at the Amicure IC curing agents and how they compare versus other technologies that's used in the flooring application. So the examples I picked here is standard polyaspartic. Again, these are mainly the, again, these are general, general formulations that I'm talking about. So what I'm talking about with standard polyaspartics are the ones that have solvent in them, not necessarily those without solvent. 2K aliphatic solvent-borne polyurethanes, also commonly used as a top coat for UV stable application. And then another one is methyl methacrylate or MMA technology. And the way I'm comparing them is, again, going back to the market trends. And I said, faster, better, safer. So I'm really looking at the features. So looking at the enhanced performance features within that group. And then again, features within the productivity or fast cure. And then, features within environmental friendliness or safer group. So if you look at enhanced performance, so one thing we talked about is aesthetics. And what we talked about here is modifying the gloss, getting the high gloss and low gloss. Polycarbamide technology, I have it in green. And in that case, because as I mentioned, you can vary the finish, high gloss and low gloss finish, similar to polyurethanes. You can do the same thing with polyurethanes through the addition of matting agents. I have the standard polyaspartic and MMA in orange, because in terms of they have a very nice finish. However, with standard polyaspartic, you generally get high gloss finish. With MMA, you only generally get low gloss finish. Abrasion resistance, I have most of them in green. Again, these are top coat technologies that work really well with abrasion resistance and chemical resistance. Pretty much they're all in green. I do have MMA in orange because, again, slightly lower abrasion resistance and chemical resistance. They are poor, again, with organic solvents. Impact resistance, again, these kind of compare more towards the urethanes. Again, it has high strength, but also high flexibility. Standard polyaspartic and MMA tend to be hard, but then also slightly brittle. Okay, now kind of get into the productivity section. And so we'll talk about fast cure and low temperature cure. So you can see the polycarbamide technology, again, similar in terms of chemistry as standard polyaspartic. So they are very fast cure. And also MMA, I would say, has even faster cure at low temperature, fast return to service. Polyurethanes in generally do not cure fast. And again, I'm talking about aliphatic polyurethanes, not aromatics. Aromatics tend to be faster, but we talk about light stable systems. So we talk about aliphatics, and they tend to be slower in terms of cure. And generally, they also have a lot of solvent. They do not cure as fast at low temperature. Handling user friendliness. In this case, I kind of have the polycarbamide technology in orange with polyaspartic. And the reason is really humidity effect. And as humidity, temperature can affect the cure time. So really, humidity can shorten the pod life, especially again, high humidity. MMA, same thing in terms of you need an accelerator to kick it off, and sometimes again, pod life is very important. And because it's fast cure, you don't have a lot of time to work with the material. Urethanes tends to be a slow cure, and also that means it has longer open time. So I have it in green. Thick film in one pass is important. Again, that's important in terms of productivity, because what we talk about is, you don't want to put multiple layers down. You don't want to keep applying multi-coats to build that coat. So you can get up to very thick coating in one pass with polycarbamide technology. That's why I have green, and same with MMA. Standard polyaspartic and polyurethanes, again, they use solvent in their formulation, so that kind of limits how thick you can apply in terms of your film thickness. Finally, I kind of get into the environmental friendliness of these coating systems. I have both the polycarbamide for VOC and odor as green. As I mentioned, the polyaspartics, which I'm kind of comparing against, and polyurethanes are solvent-borne. You can use VOC exempt solvents, especially in the US, for polyaspartics. However, so you can claim that it's VOC free, but you still will see, they will have some odor. And same with polyurethanes, because you're using solvents, they have odor, and again, they have high VOCs. MMA, in general, they have low VOC, but as you know, MMA does have a very strong odor. So you can only apply where you have very good ventilation. It kind of limits its use in indoor type of applications. So again, the key takeaway, as you can see, polycarbamide technology compares well, versus other technologies that's used in the flooring application. Now I will kind of talk about the starting formulation of the polycarbamide. So here what we have is a clear formulation of Amicure IC221, 321, and 322. As you see, and also, you can also make these pigmented, but I have not showing it here in my presentation, but I can, if you're interested, I can always give you the starting point formulation for pigmented system as well. So you can see it's a kind of simple formulation. As part A is a standard polyisocyanate HDI trimer. Part B, you can use either of these three curing agents by itself or as a blend. There's a optional ingredient of a UV stabilizer, and an important ingredient is an air release agent, and in there, and we can recommend which air release agent works well in this formulation. Okay, and these are, as you can see, is about 2-to-1 by weight, almost 2-to-1 by weight, but then in terms of by volume, it is a 2-to-1 mix ratio. Graph here, I briefly talked about it in previous slide, but really what we're looking at is viscosity build over time once you mix the isocyanate and the curing agent. So you can see the curve, the dark maroon here is the Amicure IC221. You can see that builds very quickly because this is high reactivity. IC321 and 322 are much slower in terms of viscosity build, but then you can blend them. So that's the key takeaway, is that these are all fully, all these three curing agents are fully compatible and can be combined in the formulation to modify reactivity. So that's the point I'm trying to make showing this graph, okay? And finally, just kind of give you, another properties of this technology is in terms of, let's say, water spotting. Within 2 to 4 hours, you can get water spot resistance with these coatings. And also same goes with the chemical resistance. The benefit of this technology is that you get fast property development, unlike other technologies out there. And with the use of UV stabilizer, you can see you can go up to 2,000 hours. So this is, again, accelerated aging QUVA testing, and you can get very low delta E, high gloss retention. So again, these can be applied indoor, but also exterior application. So now I'm going to talk about the unique feature of polycarbamide is that ability to get the down glossing. So in this case, actually, what you're using is Amicure IC322. So this is for a satin top coat application. Again, it's a simple formulation. Part A is a polyisocyanate HDI trimer. Part B is Amicure IC322, again with the optional UV stabilizer. Dispersant can be added, air release agent, molecular sieve, and then a key ingredient here is a matting agent to down gloss. So here we have AceMatte 3600, which is an important matting agent. It works really well in the system to get it down to a satin finish. So here's a picture show here on the right side. So this is, the panel here, what you see is high gloss finish, and that's without any matting agent added. With the matting agent, you can get down to a satin finish. So what we talk about satin finish is 60-degree gloss of less than 40. So with the satin finish, so this is, as you see the picture of a real world application. What it does is, a lot of times end users do not want very high gloss finish because it kind of shows all the small defects that you might see on the flooring. Going down, to lower gloss, you're able to hide those defects better, and it gets a more pleasing look. I guess that's another reason. Last thing, actually, I should say is that another unique feature with this technology is that you are able to get low gloss even at high thickness. So, with other technologies that for low gloss finish, generally like, waterborne or solvent-borne systems like polyurethanes, you can only apply 5 mils in one pass. And, in this case, what you do, you can get from, apply 5 mils to up to 20 mils. You get the same gloss. That's unique. And so again, productivity is ability to apply very thick coating in one pass that improves the productivity. And also, again, in terms of, it gives you better looks because different thickness, in different applications on the surface of the concrete at different areas. If you have one that's more higher gloss than the other, then again, it does not give you that nice look. So you really want a more uniform gloss throughout the whole area of the concrete or of that space. Okay. All right. So here, I kind of mentioned before, humidity, temperature has an effect in terms of working time with this technology, right? So if with Amicure IC221 and IC321, so what I'm showing here is in this 3D graph for IC221 really is how temperature and humidity affects the open time and how it affects the walk on time or return to service. So here, so on the x-axis, we have temperature. On the y-axis, we have humidity. On the z-axis, we have the open time. So in generally, what you're operating is in the ambient conditions. So let's say you're at like a 22 degrees Celsius or 70 degrees Fahrenheit, 50% relative humidity. So you can see with Amicure IC221, you're getting this 10 minutes working time, about 2-hour return to service. However, as you go towards higher humidity, you start losing that working time. The film does cure faster, but that you need certain amount of working time to be able to again apply onto the substrate. Otherwise, if you have very short working time, the coating is not going to look good. But over here again, in terms of lower temperature, lower humidity, you can see you get nice amount of working time, good amount of working time, and then even that return to service, you're still getting fast return to service. So really with Amicure IC221, the reason you would use that is when you're working in these kind of conditions of low temperature, low humidity. Okay. Now going to the other extreme is Amicure IC321. As I mentioned before, again, this can be also with IC322 as well, because they have the same reactivity. So they have slower reactivity. So really, as you look at, in regular conditions, you're in this dark purple here, you have about 20 minutes working time, get back on it around 6 hours. But the benefit here is that you still get enough working time as you go to higher humidity, higher temperature. So that's the benefit with 321, while still getting fast return to service. If you're working at lower temperature, lower humidity, you probably, again, it gives you you do get benefit of higher working time, but then return to service is a little slower. So really, again, in that case, you probably want to use 221. So the key takeaway here is really that you can blend these two curing agents together to get the balance of working time and return to service. A lot of times the customers will have multiple products, one for the winter season, one for the summer season, for that reason, because again, humidity, temperature does have an effect on the working time and return to service. All right. So I'm kind of circling back now here again, going back to the application. So as I mentioned, the polycarbamide technology is, gives you all the key benefits in terms of fast return to service, and again, it's environmentally friendly, and improved performance. So here are three examples, but there are many different examples I can give in terms of flooring systems. But here are three examples. One is thin film coating systems. In this case, the total system is less than 20 mils. So a lot of times what you're doing is adding, using very thin films to apply over concrete. A lot of times when you have a very smooth concrete floor, you don't need to apply very thick coatings. And in many cases, these are water-based systems, because water-based systems you're generally applying at less than 5 mils. Thick build self-leveling resurfacer type of systems, you can really build that very thick. And again, a lot of times is when you use it in, where you have concrete where it's not even, you need to smooth it out, or again, industrial application and things like that, where you need something more durable. What you're doing here is building the thickness through the mid coat. A lot of times you're adding some kind of cementitious or filled system, as a mid coat. You can go up to 1/4 to 1/2 inch thick sometimes. Broadcast flooring allows for both functional, a good performance, but also decorative type of application as well. In this case, what you're doing is applying, the mid coat is really a clear or pigmented system, and then what you're adding is some kind of flakes, flakes that's quartz or chips, and then you are sealing with a clear finish. Okay, so these are the three examples. So the message here with this slide is really bringing in the epoxy technology with the polycarbamide technology. So with combined use, you're able to provide really unique combination of high performance and rapid return to service. So again, for all types of application, industrial, commercial, institutional flooring application. So here what we're recommending is using epoxy as a primer, and then epoxy or polycarbamide as mid coat, and then polycarbamide as a top coat. So why would you want to use epoxy? And epoxy, the reason here, which I have underlined, is the fact that it is more moisture tolerant, has very strong physical properties. The key is it has very excellent adhesion to concrete, especially damp and green concrete. It's a proven technology. Again, polycarbamide does adhere well to concrete. However, in real world application, concrete is never the same from one place to another. Some concretes are drier, some concretes have a lot of moisture, they have a lot of salts and other things. Really, epoxy is a very robust system. It will stick to many different types of concrete. And polycarbamide, again, as I mentioned, you're reacting isocyanate, polyisocyanate with the amine curing agent. With moisture, as you know, polyisocyanate can react with water. It can cause bubbles. It can weaken the bond strength to the concrete. So in that case, again, you do not want to use polycarbamide where you have high moisture in the concrete. So that's just why we recommend epoxy as a primer. Okay. Rapid return to service is important, as you mentioned, but a lot of times people don't want to use epoxy because they are slower. So here you are pick something epoxy technology that are fast cure. And then customizable sheen and UV stability, high abrasion impact resistance is really brought in through use of polycarbamide technology. And by using the two technologies together, as you know, epoxy technology is a little lower cost, you're able to get better cost control of your whole system. Here are some recommendations of what you can use in these type of different flooring systems. So for thin floor coating systems, here are some commercial products from Evonik we would recommend. For primers, Ancomine 287 is a water-based primer. And then for mid coat, you would use Ancomine 2735 or Ancomine 41 AR 555. And then always top coat, we recommend our polycarbamide curing agents technology. Self-leveling flooring, 287, again, water-based system. Another one is actually the strong trend is towards use of moisture vapor barriers. So really low permeation where you blocking all the moisture vapor from coming up to the surface. So these are some new offerings from Evonik, Ancomine 2850. And then for mid-coat, use of urethane cement or epoxy modified cement from Evonik. Finally, the broadcast flooring system we recommend, again, 287 or 2850, or a solvent-free epoxy technology 2735. In this case, you can also use polycarbamide as a mid coat, as well. And then again, top coat is always we recommend use of polycarbamide technology. With these combinations, you can still achieve, the three market trends we said: better, safer, faster, because all of these do have are environmentally friendly and also have fast cure speeds. One thing I also want to mention is, again, you're putting down multiple layers of coating, and it's important that these coatings do stick to each other. So as what I mentioned in the previous slides, all that coating recommendations, they are shown to have good adhesion. However, as you know, formulators will usually add additional ingredients to the formulation, and they are fillers, pigments, additives, surfactants, dispersing agents, and other things, and even environmental conditions can all have impact on intercoat adhesion and recoatability. So we always recommend our customers to test the intercoat adhesion of the final formulation. You do not want to get to the job and then apply it and then see failures. So here are a couple ways to do a quick check to see if these layers stick to each other. One is the dolly pull adhesion testing, ASTM D7234. Once you put on all those layers, you want to do a dolly pull and make sure that the failure occurs at the concrete. Another one, a quick and dirty test, is tape adhesion. And again, you apply the coatings, multiple coatings onto the substrate, and then you do the scribing with the knife, and then you pull a tape and pretty much see where the failure is occurring. So again, you do not want the Intercoat failure to occur, okay? All right, so I'm gonna finish up my presentation here by giving a couple examples of a one-day flooring. And here's an example of a broadcast floor. So here you're starting out with a bare concrete. And one thing I didn't mention before is before you apply any coatings on top of the concrete, you really want to prepare the concrete first. So in generally, you're doing some kind of profiling, in this case, either shot blasting, grinding, but in general, shot blasting is preferred before applying any coating. The next, the first layer that you put down on concrete is a primer. In this case, we recommend Amicure 2850. Again, as I mentioned before, it's a low perm moisture vapor barrier. It has very good adhesion to damp concrete, very high mechanical strength. 2850 is a fast cure moisture vapor barrier. After 3 hours, you can apply the base coat. The mid coat here would be, in this case, what we're showing is Amicure IC221 321 as a receiving coat where you would broadcast flake or quartz. And what the mid coat does is helps again with the durability, but also hides the UV resistance of the epoxy underneath. So without anything on top, this epoxy will yellow over time, but by applying the polycarbamide technology on top of it, you will hide any kind of poor UV resistance of the epoxy. And finally, so 2 hours later, you put the top coat. So this is, again, we always recommend the polycarbamide technology, high gloss or satin finish, and get the improved, again, impact, UV resistance, abrasion resistance by using the polycarbamide technology. So 7 hours later, so you're done with the job. The benefits here with the whole system, again, the purpose here is to, again, protect the applicators and the occupants of the space that you're applying the coating. The benefits with these systems are it's free of nonylphenol, benzyl alcohol, which again it can emit over time. So low emission technology, low VOC technology, and these can cure at even down to 5 degrees Celsius, so low temperature. Of course, the return to service will be slower, it will take longer, but they do cure at lower temperature. And then what your resulting coating is really high performance, high durability. So the next example here is one-day flooring with thin film coating. And again, you start with the bare concrete. You're doing some kind of profiling on the concrete. Then you're coming down with a primer. In this case, in this example, I'm using the water-based Amicure 287. Its product has been around for a long time and has been successfully used as a over concrete because it does penetrate into concrete. So it's forming a really good bond. It's excellent adhesion to damp and green concrete. Another benefit with that, again, you have long pot life, so improved workability, but also it cures very quickly. After 2 hours, you're able to apply the base coat. And the base coat here, example I'm giving is the Amicure 41555. Again, water-based, use of water-based, you have long pot life, long time to work with. And you can put a clear down or a pigmented thin film, can be lightly flaked if you want. With the water-based technology, it is improved UV resistance. So that's another thing, benefit over solvent-free technology is that you get improved UV resistance, okay? And again, these water-based technology, they have long working time and also fast cure. So after 2 hours, you can get and put a top coat down. So in this case, a top coat can be pigmented. So if you're using a clear base coat, you can use a pigmented top coat. If you're using a pigmented base coat, you can just seal it off with a clear top coat. And what you get again is the benefit of the polycarbamide technology, which I mentioned before, very durable type of coating. Again, 6 hours, so 2 hours later, again, total of 6 hours, you've done with the job. And the benefits here is, the benefit here again, these are thin film application, less material is needed. So you talk about very thin coating. You have very, again, easier to apply, long working time. So for the applicators, you have a lot of working time by using water-based system. Low VOC emissions, no odor, again, with the use of water-based with polycarbamide. And these are more, again, medium type of performance durability systems, because it's thin film application. Before I finish with the summary, I think one question you might ask after looking at this is that I mentioned before humidity, moisture effect in terms of cure with polycarbamide, and why would I want to use a water-based epoxy? And in this case, you can use a water-based epoxy with polycarbamide. The key thing is that you want to make sure that the moisture comes out from the coating. So you want to make sure that 287 is completely dry, 41555 moisture is out, and generally after 2 hours application, moisture comes out. All you want to make sure is, again, you have a good ventilation so the moisture can leave the substrate before you apply the polycarbamide technology. And now I will conclude here. So again, combining the epoxy polycarbamide technologies gives you, in terms of key market trends, again, I talk about faster. So you're able to produce coating in a whole flooring job in a single day, rapid return to service, and also allows for low temperature cure. In terms of better, again, you here talk about excellent performance, excellent adhesion to concrete, dry and damp, moisture tolerance, strong physical properties, customizable gloss with UV stability. Again, better means that these coatings will last a long time before you have to replace it. Safer, and we'll talk about, again, low to zero VOC, free of nonphenol and other harmful materials. Use of waterborne epoxy also helps in terms of VOCs and emissions, and again, also no odor in terms of application. So that concludes my talk. And the last thing I want to do is, before asking for questions, is really acknowledge two people who have had a lot to do with this technology and this program. David Brown, who's a lab chemist. A lot of the data that you saw were generated by him, and then Svetlana Ivanova, who is our marketing manager. So now I kind of will ask for any questions that you have.
Okay, everyone, we will get started with our question portion of this webinar. And I just want to let you all know that we're getting quite a few questions about, will this webinar be recorded? You want to watch it later, or will the slides be available? The answer to all of those is yes, this webinar is being recorded. And once we have the recording ready, you will all get an email with the recording and the slides. So just as a note, our first question is, can any matting agent be used with Amicure IC 322 to get the low gloss finish?
Yeah, so the recommendation is AceMat 3600. And I should mention that we have done a lot of work at looking at different matting agents with this technology and getting down glossing. And AceMat 3600 works really well. It's a precipitated silica, and it has functionalized with material that allows it to come up to the surface. So as I mentioned before, you can apply up to 20 mils, and you can apply one thicker than that. And what you still see is a down glossing that can occur. And so the only way that happens is that matting agent has to come up to the surface and be able to deflect the light so you can get the down glossing. So what we found is AceMat 3600 is unique in that it does do that in terms of comes up to the surface. Not other matting agents are not as effective. So I would definitely recommend use of AceMat 3600 to get the down glossing.
Okay, next question. Can solvents be added to the polycarbamides to extend the working time?
Yeah, so one of the things I mentioned is that you can formulate polycarbamide technology to make it solvent-free, and that's really the benefit you get. A lot of customers like that they can make a solvent-free system, again, for the benefit of low odor. But for those who want to add solvents, yes, you can add solvents to extend a little bit of working time. And generally you can use the VOC exempt solvents that's in the US. And we have a couple other recommendations we can always give you in terms of what solvents you can use with these technology.
Okay, great. Next question is, can we obtain satin finish with Amicure IC 221 or IC 321 if we use the recommended matting agent?
That's a good question. So really, IC 322 was developed for the purpose of being able to down gloss. We were not able to down gloss 221, 321. You can get down glossing maybe to more semi-gloss finish. However, really I would recommend use of IC 322 because it's a lot more effective. With the combination with AceMatte 3600, you really can get down glossing, down to, again, satin finish.
Okay, great. Next question. What is the main difference between polyurethane and polycarbamide?
So main difference, again, polycarbamide is a polyurea technology. Polyurethanes is, again, urethanes is reaction. So, in terms of basic reaction, you talk about polyisocyanate in both cases, but in terms of curing agents, for polycarbamide is amine functional, for urethanes is hydroxyl functional. So that hydroxyl functional with isocyanate is much slower, especially when you talk about aliphatic systems. So this is where the benefit comes in, is that use of amine curing agents. They can cure faster. In the past, polyureas in general tended to be have less working time, but again, with this technology allows for a little bit more working time, open time to be able to apply. As you can see, in terms of, I had this in my slide in terms of comparison versus the two. They have very similar performance in terms of aesthetics and other things. The key difference is the speed. The key difference is, in terms of being able to get fast cure and low temperature cure. And so the benefit is with use of polycarbamide technology.
Okay, great. What is the maximum gloss achieved with these hardeners?
Oh, so maximum gloss with this hardness. So you're talking about gloss, very high gloss. These are similar gloss to other urethanes or others. So you get it depends, let's say 60-degree gloss of over 90, over 100. So there's no difference with this technology. Similar to standard polyaspartics, standard polyurethanes. You get very high gloss finish.
Okay, the next question is asking what is the actual size of the phrase thick film in one pass? Like, what is the actual thickness of the film?
Yes. Yeah, I guess good question. What we mean is usually 20 mils in one pass. In general application, not many people will put that down to such thick coating. Again, for the reasons of cost, but most of the time it's around 10 mils, 10, 15 mils, but you can even go down up to 20 mils in one pass. And can you get even higher than that? Yes, you can get thicker than that, but what will happen is you'll slow down the cure speed.
Okay, great. Next question is, can this technology be used on metal surfaces also, or is it designed only for concrete and mineral substrates?
Good question again. This is, again, what we talk about, the three curing agents, IC 221, 321, and 322, were designed specifically for flooring, so over concrete application. We do have new offerings for metal applications. So I would not suggest using these curing agents because we have other curing agents for metal application, which I would recommend to use those. And if you have any questions about that, we can always give you the information on what curing agents you can use for metal application. Okay.
Okay, the next question is, can I use this top coat directly over a self-leveling concrete?
Yes, as I mentioned before, these will stick well to concrete. They have very good adhesion to concrete. The reason I kind of had a couple slides on use of the synergies between use of epoxy and polycarbamide is that really, and where you have high moisture levels in concrete, I would not recommend using polycarbamide directly to concrete. But to dry concrete, yes. But a lot of times, sometimes you don't know in the field how much moisture you have, and over time, how much moisture you'll have. So I would, in generally, for a robust system, I would say use epoxy as a primer. But polycarbamide technology can can be applied to dry concrete.
Okay, next question. Is it possible to apply polycarbamide-based systems outdoors on a terrace, for an example?
Yeah, so this is, the advantage of using these technologies is the fact that it has UV stability. You are able to use for exterior application.
Okay, this question is, what is the best season to apply the system in the US, especially in a subway area? Do you have any recommendations or?
Yeah, as I kind of talked about the three different curing agents and they have their different reactivities, that allows for applying it all seasons. I mean, this is kind of, the benefit here with polycarbamide technology and other fast cure technologies is that it kind of allows you to get to that winter season or late fall, early spring season and still be able to apply these coatings, where other technologies, you have to wait until it can get warmer. So based on, again, for colder temperatures, you want to focus more on the 321 type technology. For, again, warmer, high temperature, high humidity, you want to focus on the 221 technology. And again, you will blend the two to get that kind of cure performance that you want.
Does the
Okay.
polycarbamide-based systems need a primer? And if so, what primers should be used?
So as I mentioned in terms of primers, so I gave examples of different primers in my presentation. So these were based on the epoxy technology. So again, we have solvent-free epoxies or water-based epoxy primers that can be used underneath of polycarbamide. And I can explain what the benefits are with using epoxy technology under polycarbamide. And main reason is that robustness in terms of good adhesion to damp green concrete.
Okay, can you patch repair damaged areas with this type of system?
Yeah, I mean, as I said again, patch going directly on concrete. Yes, you can use this as a patch repair, but in general, if you're doing patch repair, a lot of times using epoxy type technology. But if where you need a UV resistance, where you want UV stability, of course, yes. But again, as I mentioned, if you're going directly on concrete, you want to avoid kind of concrete that has moisture, high levels of moisture in there.
Okay, our next question is about returning to service. So, how soon can these materials be returned to service with rolling loads? For example, in a hospital with hospital beds or in a warehouse with forklifts.
Yeah, a lot of times these are what we call, when I talk about 2 hours return to service, 6 hours return to service, it's usually walk on time, and generally, what we say, even if, so return to service for heavy loads, so for, let's say, garage, you apply it, garage the first day, usually within 24 hours. Most of these coatings, you can come back and park the car on top of it. So usually within 24 hours, but for much heavier loads, forklifts and things like that, you might be maybe 48 hours or so. It all depends. Again, cure conditions play a big role. If they are in colder temperatures, the coating will take a little longer to cure. If it's in the warmer, high temperatures, the coatings will develop the properties much faster. So it depends on the conditions, but generally 24, 48 hours, you back on, on the floor.
Okay, great. Can this be a non-skid application, and can you add more material to make this a non-skid application?
Non-skid, usually a lot of times what you do is through broadcast, which I kind of talked about. In this case of broadcasting, sometimes with aluminum oxide or other things like that, or again, flake or coarse broadcast is done. So you have a little rougher surface. So a lot of times broadcast flooring is done, so you have a little bit of, you don't have that smooth surface, so you can make it a non-skid type flooring. But then there are many additives you can just add to improve the skid resistance. But again, generally, even if you don't add any kind of broadcast, you still have very good non-skid type of properties with these systems.
Okay, this is going to be our last question. Can this technology be made sprayable for all coats?
So another good question. You can make it sprayable, but I'm thinking, again, in case they do cure very quickly. So again, unless you're adding a lot of solvent to give you a lot of working time, uh, if you want to make it sprayable, you can use a component type of spray application, so you have enough time to be able to apply. Again, we are talking about flooring application where most of the applications will be rollable, and kind of like a rollable or squeegee type application. But then, we have, as I said, curing agents for metal application where it's actually sprayed, and those are specific for the application. We have long enough working time with the use of solvents in it. So yes, you can make it, but you probably would need to add some kind of solvents or use a pluricomponent spray type of equipment.
Okay, thank you all for attending today's webinar. Just as a reminder, we will send you a link of the recording of today's webinar so you can watch it at any time and share it with others at your company. We will also follow up to any questions we weren't able to get to today. Thank you again for attending, and have a great rest of your day.